Welcome to this lecture on the basic vocabulary used in programming. Programming is a discipline that involves creating software and applications that can automate tasks, perform calculations, and make decisions. To get started in programming, you need to understand some of the basic concepts and vocabulary used in the programming world. In this lecture, we will discuss some of the most common terms you will encounter as a beginner programmer. Variables. You have heard this term in the previous lessons, so what does it mean? Variables are used to store data in a program. They have a name and a value, and you can use them to perform operations, calculations, and decision making in your code. In the most programming languages, you can define a variable by specifying its name and value, like x equal to 10. Here we have defined a variable named x and assigned it a value of 10. We can then use this variable in other parts of our program to perform operations like this. Y is equal to x plus 5. Here we have defined another variable named y and assigned it the value of x plus 5. Since x has a value of 10, so y will have a value of 15. Data types. You must be familiar with this term at this stage. So data types refer to the kind of data that can be stored in a variable. In most programming languages, there are several data types to choose from, including integers, numerics, strings, and booleans, etc. We have covered them in depth in the previous lessons. Here are some examples of data types in R programming language. You can define an integer variable like this: x is equal to 10L, where L represents that it's an integer value. Without specifying L, R will take this variable as a numeric variable. So you can define a string variable like s is equal to hello world, which is same as initiating character. You can define a boolean variable like this: y is equal to true. You can initialize lists, data frames, matrices, etc. We have covered data types in depth. You can watch those lectures if you haven't watched yet. Well, operators are used to perform operations on variables and values. There are several types of operators, including arithmetic operators, comparison operators, and logical operators. Let us go through each type of operators. So, arithmetic operators are used to perform mathematical operations on numerical values. R has several arithmetic operators that can be used to perform, such as addition, subtraction, multiplication, division, and other operations. Here are some most common arithmetic operators in R. Plus sign, which is the addition operator and adds two values together. For example, 2 plus 3 would return 5. Minus sign is the subtraction operator, subtracts one value from another. For example, 5 minus 3 would return 2. Asterisk is for the multiplication operator, multiplies two values together. For example, 2 asterisk 3 would return 6. Slash is for the division operator, divides one value by another. For example, 6/2 would return 3. Power symbol is used for the exponentiation operator, raises one value to the power of another. For example, 2 raised to power 3 would return 8. 2% symbols represents the modulo operator, which returns the remainder of dividing one value by another. For example, 7 modulo 2 would return 1. Here are some examples of using these arithmetic operators in R. In the first statement, we are assigning x to the value of 2 and y to the value of 3. And then in the third statement here, we have initialized another operator z, which is equal to x plus y. So 2 plus 3 is equal to 5 and would be the value of z. In the next statement here, we have initialized another variable a, which is equal to x multiplied by y, and so would be equal to 6. In the next statement, we have initialized b variable, which is equal to y raised to power 2, as y is equal to 3, so b will have a value of 9. In the next statement, we have initialized c variable, which is equal to 10 divided by 3 and will have a value of 3.33. In the last statement, we have initialized d variable, which is equal to 7 modulus 3, so it will have a remainder of 1 and d will be equal to 1. In addition to these basic arithmetic operators, R also provides a number of other built-in functions for performing more advanced mathematical operations, such as sqrt function for calculating square roots, sine and cos functions for calculating trigonometric functions, and log function is for calculating logarithms. In R, the order in which arithmetic operations are performed is determined by operator precedence. Operator precedence is a set of rules that dictate which operators are evaluated first in an expression. Here is the order of operator precedence in R. First is parenthesis, then exponentiation, then multiplication, division, and modulo. Here, as we have three operators on one level, so R will perform first from left to right, and then addition and subtraction on same level, so will be performed from left to right. This means that if an expression contains multiple operators, the ones with higher precedence will be evaluated first. For example, 4 plus 5 into 2. In this expression, multiplication has higher precedence than addition, so 5 into 2 will be evaluated first, resulting in 10. Then the addition operator will be performed, resulting in 14. If you want to change the order in which operations are evaluated, you can use parentheses to group parts of an expression together. Anything inside parentheses will be evaluated first. So for example, 4 plus 5 in the parentheses into 2. In this expression, the addition inside the parentheses will be performed first, resulting in 9. Then the multiplication operation will be performed, resulting in 18. It's important to keep operator precedence in mind when writing complex expressions in R to make sure that the operations are being performed in the correct order. In R, the comparison operators are used to compare values and return a logical true or false, depending on whether the comparison is true or false. Here are the comparison operators in R. Two equal signs represent is equal. Exclamation mark before equal sign represents not equals. Less than symbol for less than, greater than symbol for greater than, less than and equal symbol is for less than or equal to, greater and equal symbol are for greater than or equal to. Here are some examples of using comparison operators in R. So we are initializing two variables x and y with the values 5 and 10 respectively. So to test are they equal, we will write x double equal sign y and it will return false as they are not equal. Then in the next statement we are asking if they are not equal and it will return true as they are not equal. In the next statement we are asking whether x is less than y, which is true and would return true. In the next statement we are asking if x is greater than y, which is false and would return false. In the next statement we are asking if x is less than or equal to y, which is true because x is less than y and would return a true. In the next statement we are asking if x is greater than or equal to y, as x is neither equal to y or nor greater than y, so it would return false. Logical operators are used to combine logical values and return a logical value. Here are the logical operators in R. AND sign is used for element wise AND. This straight line is used for element wise OR, and the exclamation mark is used for negation. Here are some examples of using logical operators in R. So we are initializing two variables x and y with the values true and false respectively. So we are testing x and y, which is equal to false, as AND operator only returns true when the both elements are true. In the next statement we are testing element wise OR, so it would return true as OR operation return true if any one of the element is true. Next we are using negation sign to change the value from true to false or false to true. So here x is true, so negation x will be false. It's important to keep in mind the order of operations when using logical operators in R. Just like arithmetic operators, logical operators have a specific order of precedence. Not is evaluated first, followed by and then OR. If you want to change the order of evaluation, you can use parentheses to group parts of an expression together. Next, escape sequences in R are special characters that are used to represent characters that cannot be typed directly into a string or text literal. They are represented by a backslash followed by a character or sequence of characters. Here are some common escape sequences in R. Double backslash represents a backslash character. Backslash single quote represents a single quote character. Backslash double quote character represents a double quote character. Backslash n represents a new line character. Backslash t represents a tab character. Backslash r represents a carriage return character. \b represents a backspace character, \f represents a form feed character. Here are some examples of using escape sequences in R. You can go through them later on. I will provide the slides in today's blog post as usual. So escape sequences can be particularly useful when working with strings that contain special characters or when writing regular expressions. However, it's important to use them correctly, as using the wrong escape sequence or failing to escape a special character can cause errors or unexpected behavior in your code. So one basic concept we should remember and never forget it is that we should write a code in a way that it takes some input, some data or instructions, and then it processes that, work that out, and then gives the output. This should be the sequence that you should follow when developing some code or a program. You should always write it in a way that it takes input or instructions, then process that, and then returns the output. So never forget this basic rule while developing some code or a program. So there are a few more concepts that we will discuss in depth in future lessons, and that are control structures. They are used to control the flow of a program. They allow you to perform different actions depending on certain conditions. There are several types of control structures, including if-else statements, for loops, and while loops. Subsetting is very important. Often you need subset of data for your analysis or work. So it's always better to carry that subset only, as we know that in R, dataset is stored or loaded in computer memory. So it is always better to subset the dataset according to our needs, so we should work efficiently. Functions. These are set of instructions that you write and store for reuse. Loops functions. There are some inbuilt loop functions that we will study in depth, and these functions are really useful as you go ahead. So these were some basic vocabulary or concepts that we often use in programming world. So if you might be wondering what does these terms means in our last few lectures, then I have got you covered here with this in between lecture. So see you all in the next lesson, where we will start subsetting in R.